Welcome back to Coding Escape, the last of the series. We're going to tackle the Curse of the Five Warriors, which is supposed to be the hardest one. Not hardest in logic, though. Hardest in code, which is what I want, because the one we did before, Curse of the Azteca, whatever it was called, Aguateca, that was just badly written, and the logic was a bit confusing. Hopefully this one's not as ambiguous. I have done this before, but it was so long ago I don't remember anything from it. Alright, so get ready. Okay. It's a bit loud. Hang on. Alright. Oh, let me just get my tea. And off we go. Launch. Right. I don't know if this even has music, does it? Oh, there is. Maybe we just listen to this. Okay. Let's have a look at these things then. We've got a map of things. Okay. We've got a conversion thingy. I don't know what that is. Some mysterious and incomprehensible letters written on these 3 tombs. Just a bunch of letters. Okay. Okay. I probably should have written that down. So we've got a series of bells. A wall with a magical path between the stones. So we've got this. Okay. We've got 4 headstones that we can move up, down, a series of ups and downs. So those bells could be the sequence. Okay. And then we've got numbers. Is that, like, can we recognize this area? So that is the, there's a chapel. Is that this chapel here? And these are the gravestones? And the castle would be like there? I think so. So that means we're standing like at this crossroad. Yes. this crossroad is that. So these headstones, these, and the numbers are like 994, 995, so on. Okay. Alright, what do we want to do? Let's write down this bell. Let me just get some paper. Alright. Up. Down. Down. Up. 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 Down. Up. Down. Down. So... try that, I don't know. Up. What? So that one was just up, huh? Wait, that was just a single input, was it? Yeah, it was. We can't... Oh, hang on. Up. Down. Down. Huh? Up. Down. Up. This is just like a memory puzzle. Up. Down. Up. Simon Says puzzle, whatever. Up. Down. Up. No. Up. Down. Up. Up. Down. Down. What? I'm confused. Up. Down. Up. Up. Down. 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 Up. Up. Down. Up. Up. Down. 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 So one more down, and then one more up. And then where is the line going? Down. Okay, we did it. That is connected. That's that grave. This is probably one of the sequences we need. So we tried the bells on that one. It's probably on one of them that we need to use the bells. So let's say up, down, down, up, 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 down, up, down, down. Okay, so that one is the bells. I'm guessing we don't want to reuse the bells. Like, let's try it anyway. Up, down, down. Up, up, up. Down, up, down, down. A string containing the wall and the magical path. Let's have a look. Have a look at the wall. That's the wall. Like, I was going to use code to extract the ups and downs, but it looks like we could just do it by hand. So it's up, 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 down, up, 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 down, down, up, up. Maybe we should use code for this. It wouldn't be hard. Yeah, okay, we'll use code. So we get a path, and what we're trying to do for each column. We're just trying to say, okay, first put it into a grid. So it's a new line separated. Ring. So grid. Grid equals that for row in wall dot split on the new lines. Grid dot append row. Just test this out for row in grid print row. Okay, and then what we're trying to do is say for each column okay, m equals length n, m equals length of grid, length of grid 0, so that's just the dimensions, for j in range m. So for each column, So we'll record the height of the previous line. Oh wait, we got a vertical here. So what does that mean? Oh, so I think all right, basically every time we see a line, we have to look to the character to the left of it and say if it's on in the same row, that means it's an up. And if it's not in the same row, that means it's a space, it's a down. That's how we know. So we don't need that. Result equals that. For I in range n, if grid ij is the vertical line, then we look at the space to the left of it. So if grid ij minus 1 is a underscore, then that was an up. Otherwise, it was a down. Then we just return that list. Alright, that was that. And this gravestone, I assume, is not. Is not that because we don't have that input anymore. Okay. So what other source do we have? We've got these letters. Do we see any sequences around here? Got letters that could mean something. Oh. It's giving us a clue. So it was saying one of these. Oh, it even had the triangle symbol. Okay, so what it was saying was the tombstone with that line, which was that one, was going up on a vertical line. Yeah, so that was the steps. This one down here was the bells. Up for a high bell. I guess a smaller bell means a higher. Smaller. I don't know. The one we haven't done is this one. Wait, and the fourth one, which is torn off, that was the memory puzzle. Okay, yeah. So this one's saying E means up and G means down. No, because there's no E's and G's. Oh, it's consonants. Vowels and consonants. Okay, probably. So, say, so it's consonant, the vowels go up. It's called letters if car in A-E-I-O-U. Result dot and up. Else result dot and down. So we started with down. Down, down. Down, up, down. Or is it actually just E's and G's? This example is misleading because there's no G's. Okay. Yeah, that actually can work. Okay. So far, pretty good puzzles. Make sure we don't miss anything before we go in. In we go. Can't go back anyway. Alright, what do we got? The location of the castle owned by each clan. So we got the name and the number. Okay. Very similar to a puzzle in the video game Room Part 3, which I played recently, where you're combining crests to make crests. It looks like that's what's happening. It's like you're taking the color of that one with the symbol of that one or something. An alliance between 4 clans gives birth to a new clan. Ancient heraldic law dictates the way the new clan's crest be created out of those. Yeah, okay. So if you... Where does this symbol come from? So this tells us where each... So this color goes here, this color goes here, this color goes here, that color goes there, that symbol goes there, that symbol goes there, that symbol goes there. Oh, there is that symbol. Okay. That's how you make a crest. Okay. There's an inscription that reads the 5 castles of our alliance. Sequence of directions to turn the shield. What do you mean turn the shield? Turn what? I don't know what you mean by turn the shield. Okay. The name on the panel you wish to press. Okay. I've got some shields up here. King Noah. They're all looking at somebody. Is that the puzzle? Oh, I kind of remember something like this now. I think he's looking at... Can't tell really. Him? Connor? Connor's looking at Isabel. Isabel's looking at Nicholas. Oh. He's looking at him. He's looking at him. He's looking at her. She's looking at him. He's looking at him. He's looking at her. She's looking at him. So, what does that mean? Nicholas Pierce is the odd one out. What does that say? What is 7 characters ending with Y? That probably narrows down what castle. Oh, look, it's BESR. Okay. So that we should be able to filter the names of castles to know what castle we're in. Anything else? Okay. Our times. Our times. Yield 3. Turn the Turn the shield 3. Let me write this down. Turn the shield 3. To the left, to the right, to the... to the left, and twice to the right. Turn the shield 3. What was it? 3. Turn the shield 3 times to the right. F. F. times three times to the right, 4 times to the left, and twice to the right. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. Turn the shield 3 times to the right. 4 times to the left. And twice to the right. Okay. So I think whatever this puzzle is saying is that Nicholas Pierce is the odd one out, because I don't know. We'll just write down Nicholas Pierce. That tells us the rule, yeah. So we can use that. Let's figure out what castle we're in. So we know it's 7 characters ending with Y. So for list D in castles, so the format is we've got clan name, number, for Crombie. Wait, so we want the clan name, right? Okay. So name equals D clan name if length of name equals 8. 1, 2, 3, 4, 5, 6, 7, 8. And name dot ends with, is that a method? Y print D. Let me just see what happens. Okay. Now we know there's an E, a B, an S, and an R in the name. And all X in name for X in. Let's make sure this is lowercase. So it's EBSR. Raspberry. Raspberry 41. So this is Raspberry Castle. Does that mean we know the crest? For D in clans, if the clan name equals raspberry, print D. Oh, it's just called name this time. Corners. Print the corners. Let's just try and make this readable. For X in the corners. X. All right. Which order does this go in? Do we have an example? I would assume it goes clockwise or something like that, but do we have a like a hard example to use as the baseline? I assume it goes clockwise from the top left. We don't really have an example. Alright, fine. That is a flag. What do we want to do with it? Name of a clan. Okay, well we know the name of the clan. Raspberry. Is there not a P in raspberry? No. Well, sometimes there is. I don't know. In this case, there isn't. Okay, so... we're still able to do this? So there's two... they're waiting for us to fill in another one. So we can figure out... we don't know what that fourth one is. Hang on. So pressing raspberry added that top right one, not the middle one. Okay. Is that all the information? What is the final thing they want us to input here? The, there's nothing else for us to interact with. There's this. Okay. Okay, so we know we're in Raspberry Castle. And we know that Raspberry Castle has this clan thingy here. And we know that... but that's not Raspberry, is it? So let's have a look. White, star, 4, blue. Yeah, it is. Oh, no, not necessarily. Red, none, 0, none. Oh, so it's going row by row. And then red, none, 0, none. White, star, 4, blue. Okay, so that is Raspberry Castle's crest. And then we've got some other castle's crest, some other castle's crest, some other castle's crest, and then the middle one. An alliance between 4 clans gives birth to a new clan. Alright. Now, if we know... so I think they're expecting us to press the name of this clan here. And to do that, we need to first figure out the sum of the 4, and then extrapolate, kind of backtrack to see what this should have been. So the sum of the 4 will be like... no, wait. Yeah, the middle one will use these 3. But we can't infer what the bottom right one would be from that. Okay. No, that's not the approach. We know it's the top right segment is green. Let's have a look, see if we can find any green ones. So we didn't need to find raspberry. It helped us understand how this works, though. So, don't use that. So green. All right, so let's say corners equals d corners. If corners, so the top right, color is green and symbol type it doesn't have any symbols. Well, we can't see any in that segment, so I assume it doesn't have any symbols. Is none. Print D. Alright, let's see how many. There's this many. The blue comes from the top one. Melbury, Hobbingstory, Brielli, MacThomas, Ferguson, Nicholson. What? Are we supposed to do something with this? Is that a partial flag there? Because, well, there's also one there, and it's different. That's something else. Wait. Okay, so that one is looks like it's that. That is none of them. I mean, it could be the bottom right, but then this one is none of them. I don't... What do these flags mean? They can't both be the bottom right one. Unless that is not the top left. You can't tell. You can't really... There's one up there. That one... looks like it could be either the bottom left or the top right. That one is the top left one. That one... Can't zoom in on this. That one could be either of those two. But then these two don't fit any of them, so... Also, what's up with the numbers? Why do we have numbers? The only reason to use this was to find the name of the castle. But we could have done that using this, because they both have the names of the clans in them. So was there a reason to use the numbers? Like, can we see out the window or something? Like, are we by the sea? We know we're by a graveyard or a church. I don't know what this map's for. I'm a bit confused now. Oh, there's another flag here. That one has stars. That's that one? So there's 5 here. Alright. Let's assume then that this one corresponds to the top right. That one's the top right. That one is the top left. That one is bottom left, I suppose. Why is it done like this? And then these two are the middle one. Now, the spots. Let's assume this one then is the middle. That would mean the bottom right one is this, which looks like the top left segment is white. Let's have a look at these. Okay, they're all white. It looks like it's blue rectangles. Rectangle, and it's blue. Alright, I think it's Ferguson then. Go with Ferguson. Do we just... Okay. Now we just need one more, which is the combination of the 4. Okay, so now we need to say... We know what the top left square would be, right? It follows this rule. Top left of the result will have color. It's blue. We know it's blue of the top left one, and the symbols will be extracted from that. So it will be blue with orange circles, 3 orange circles. I mean, we already have a thing there, so that already narrows it down. Let's try that. So corners. Top left equals d corner 0. If, let's say, top left color equals blue, and top left symbol type equals none. So that's a start. But it's not going to be enough. It's all those. Okay. So let's say top right equals 1. So the top right no, what are we trying to do? No. Symbols should be orange circles. Disk? What did they call it? And symbol amount equals 3. And symbol color equals orange. It's already got that. Okay, fine. Let's just put it in anyway. So it's narrowed down to these 4. Then we want to look at the top right. And we know that the top right, the color of the top right will be the background color of the top left crest. So if top right color equals, so the top left segment of the top right crest, so white, none. What? Top right. Let's print top right. We've got red, red, orange, red. Did I get this wrong? Color of that. Oh, white is special. So it's not... White is not a color. No, white is a color. I think it doesn't matter whether it's on the left or the right. It's just there are 2 opposing segments which are pure color, and there are 2 opposing segments which are white background with a symbol. Doesn't matter which way around it is. And so you take the color of the colored space and you take the symbol of the symboled space. In that case, we would want the top right color to be red, I guess. And so it's one of these three. And the symbol would just be whatever the symbol is on that top right one. I see. So it'd be blue stars. Star or blue. So it's Campbell. We haven't done anything with this. Nicholas Pierce. Or King Noah. I don't know. We still have access to the flags and the castle numbers. And this, apparently. Oh, we're lighting these up. So we lit up Raspberry, that one, and that one. Oh, fine. We need to find the other two. Damn it. Okay. Okay. So we want top left. This time we want blue. Get rid of this. So top left color is blue and top left symbol is none. Top right, and then we want so top right color is white and symbol is disc. Let's try that. None. Top left is blue and top left symbol type is none. Oh. Those ones, okay. And we want discs. Okay, here we go. 3 orange discs. That's the first one. Anderson. Mr. Anderson. Okay. And then this time we want red. And so there's these two. 3 discs which are blue. So it's Arbuthnot. That was a good puzzle. There is a path that connects all the castles of the Alliance. This path does not pass any other castle. This path starts at Campbell Castle, where the 4 clans became one. This path is the key. Hang on. Should I be writing down the names of these castles because I don't remember them? It was Raspberry, and then we had Campbell. So at the bottom left it was Arbuthnot. And then the top left was Campbell. And the bottom right was what? And the middle was what? Oh, I didn't write these down. Might not need them. Oh, okay, we've got them. Hang on, hang on. Anderson, Raspberry, Arbuthnot, Ferguson, Campbell. And Campbell is the center, right? Okay. So... Okay. There's a path that connects all the castles of the Alliance. This path does not pass by any other castle. It starts at Campbell Castle, where the 4 clans became one. This path is the key. God. Alright, first let's get the numbers for each of these, so... For castle in castles, if... Okay, what is the format here? If castle clan name is in clans, print castle. Right. Not. Raspberry is 41. Campbell is 50. Arbuthnot is 71. Anderson is 86. Ferguson is 108. And we have this that we haven't done anything with. For some reason we could still press clan names. This path does not pass by any other castle. Starts at Campbell, where the 4 clans became one. This path is the key. Alright, so Campbell is 50. So... down there on the bottom there, okay. There is a path. But where are we supposed to get to? It connects all the castles of the Alliance. Do we need to whip out paint here? We... Alright, I'm just copying this into Paint. There we go. Let's kind of resize that. Okay. Whatever. Alright, let's have a look at this. So we start at 50. Circle it in red. So 50. Now we need to go to so we can't go past 49. We've got to go to either 41, 71, 86, or 108. So we could go along this path to 108. We can't go this way because 97 is not one of them. So we have to go here. Okay. And then we go to this junction, and then we got to go to 77 is not one of them, 66 is not, so we would have to carry on this way. 14 is not one of them, 41 is. So we have to go this way. So we've done 50, 108, 41, 86 and 71 are left. '71 is there. 86 is there, so we have to go like that, and then that. Okay. What was the point in that? What was the task again? To starts at Campbell Castle. This path is the key. The only thing we can get from this is the order of the numbers. Like, what else? The shape? Well, the shape doesn't tell us anything, does it? This path is the key. So... But we're not being asked for... What are we being asked for? Now reacts to an ordered sequence of clan names. Oh. So it's... Oh, okay. So we just got to give the order. So where's the list? Okay, that's that list. So we want... To start with Campbell. Then we go to Ferg. Then we go to Rasp. Then we go to Arbuthnot. And finally Anderson. The only information we haven't really used yet is... Okay, they've taken away access to all that database stuff. Good, so we don't have to worry about that. But we still haven't used this. Fine. Oh boy, more puzzles. Okay. We can remove some of these that we aren't going to use anymore. Alright. What do we have here? Candles with names on them. There must be... These must be linked to the ritual that created the curse you are here to dispel. Mm-hmm. Here lies in the only tomb to have been taken from the castle cemetery to honor their memory within this sacred place. This crossbow belonged to that buried so-and-so. Family tree, da-da-da. The fact that the total number of his descendants is equal to 48, the exact age at which he da-da-da died, probably. This axe belonged to so-and-so, first cousin to the grandson of the... Oh, God. Family tree stuff. The only regret was not having more than one child. Oh, boy. Thief, your eyes betray you. The true owner of the axe can be traced back through guilty looks. I think I know what that means. So we go backwards through the looks to get to King Noah. So King Noah had the axe. Okay. King Noah had the axe. So King Noah is this first cousin to the grandson of the only child of... Oh, God. Her only regret was not having more than one child. But King Noah was a king. Was it a woman? Or is there a... I don't know. The true owner of the axe. So we know who the true owner of the axe is. Wait, so which one's the axe? Sword. Axe. Okay. Do we have a list of the candles? Okay, let's try... But do we have to... king. No, like that. I mean, how are we supposed to do it? Is that a... Is that King Noah there? Club. Wait, he's holding a club. No, a... What is that? Flail? That is Oscar Manning. Oscar Manning has that thing. We've got axe. A double-sided axe. So there's an axe and there's a double-sided axe. And he said... Oh, but he's holding the double-sided axe. Ah. King Noah II. What? Okay. So that one's a crossbow. That one's a flail. That one's a sword. So the flail we know is Oscar Manning. Alright, so we've got the flail. That's that one. Oh, we can go back out here. This empty patch of ground is lower than the rest of the terrain. So there's a grave that was there. Oh no. Hang on. So up on the map, can we work out which grave that is? So that's the chapel. This junction here. We walk along here. Then we'll have 1, 2, 3, 4 graves alongside us. Let's have a look at that map. So that's the chapel. We're standing here. We have 1, 2, 3, 4. So that one is 894. Yeah, pretty sure that's 894. So for grave in graves, if grave number equals 894, print grave Oswald Sherrington. What? Okay, so Oswald Sherrington is dug up for some reason. What does that tell us? That guy there is Oswald Sherrington, and he's got a sword. So... boom. That's that. true owner of the axe can be traced back through guilty looks. King... Okay. His name is not King Noah II. Because king is just a title. You could be a king and you could not be a king. Like, before he was a king, he was not a king. So we just need to know his name. Let's try and find his name, his actual full name. Name. So it basically contains Noah. Alright. We're not using that anymore. For D in for person in nodes, if Noah in person, what is it, name? Yeah. Print person. Or... No, I don't think you can do that. Can you? No. It's dot contains, isn't it? Or... no. No, you can do that, but do we need to adjust for capitalization? Maybe he's just not in there. Okay. King Noah. Okay. There's no Noah. Oh, but this family tree is just specifically this family. It's not, he's not necessarily in there. I see. They've taken away this one, okay. So we know that, we believe that King Noah carries the double-sided axe, but... if we don't have a list of the candles... I'm not sure what his name is then. Noah... something. Or maybe it's... like the Noah Raspberry? But... there's no Noah. raspberry. Raspberry. No, this is one family. Oh no, did we just try Noah Raspberry? Let's try it. Noah Raspberry. Alright. I don't understand the Noah thing. What if it's the other way around? What if... What if it's Nicholas Pierce? He says traced back through guilty looks, so you should be going backwards. He literally says back. Okay, let's try Nicholas Pierce. What? So why does he say back? That's stupid. Alright, whatever. That's that. Now we need to find the crossbow and the axe. Okay. Total number of his descendants is equal to 48. The exact age at which he died. Alright. And then this one. First cousin to the grandson of the only child of... Okay. We have to do some actual coding now. How do we do this? So we say... Okay. So to start with, we have to make a database here. Family equals, let's say that. For person in nodes, let's say family person ID equals Just put the person. So that keeps everything in the family, so we don't have to cycle through nodes anymore. Now, we would like a method of working out how many descendants somebody has. Descendants of person ID. Alright, so to work that out, we want to say if family person ID child IDs. So if he doesn't have any children, then we return 0. Else, for child ID in else, return sum of, so it'll be, so for each child, that's a 1 plus all of their children except, what if there's some incest going on here? Then you'll be double counting, and there probably is, but like, you know, like second cousin or whatever, that's fine. In that case, what we need to do is create a set here. Descendants equals set. Okay, so we have to say for child. So we actually have to return a set of descendants. So return an empty set. If they don't have any children. Otherwise, result.add child ID, that's a descendant. And result combined with descendants of child ID. So we recursively fetch the children of the children. No, it's plus equal? No, it's I think that's right. So we add, or just say dot union. Descendants. No, we were right the first time. There we go, because it didn't like that. Okay. And then So that actually compiles. So what are we trying to do? Find somebody who is male and has 48 descendants. Okay. For person in nodes, if person gender is M and length of descendants of person or ID num person in nodes dot items. Nodes, not nodes, family. So if they're male and 48, print person. Remington Northcott. We came up with one person, so that was the crossbow. Now for the hard one. So we know she's female, and she has less than or equal to one child. We'll assume exactly one child. Let's start with that. And length of person child IDs is exactly one person. It's all of these possibilities. First cousin to the grandson of the only child of... Oh, God. What exactly does that mean? So some of these don't have mothers or fathers. If they are... If we know they're a first cousin... So what's a cousin? A cousin is, your parents... One of your parents' siblings' child. So you have to have a parent and you have to have a grandparent in the tree for this to be valid. And so we'd have to have person father ID is not equal to -1 and mother is not equal to -1. Now, we could just guess each of these, and we'll get a penalty of like 3, 4, 5, 6, 7 minutes at most. On average, like 3 or 4 minutes. That's actually worth it. Do we really want to code this cousin thingy? Anything else we can do? Is that the hard definition of a cousin? Yeah. Let me just check. Definition of first cousin. A child of one's uncle or aunt. Okay. So this person has 4 grandparents, up to 4 grandparents in the family tree. Must have at least one, but there must be at least one grandparent who has 2 children. So the grandson. Alright, so we want to make a list of the grandparents, I suppose. Okay. Father equals... family... that. So we want a list of grandparents. And then we want to say... if he has a father, because they might not... the family tree might not extend that far. If father... grandparents dot and it's gonna be father's father and mother and then we want this whole thing again, but with mother. Mother is... so if rent grandparents. Sometimes you have 4, sometimes you have 2. Okay. Getting there. Grandson of the only child of... they have a cousin. So we can now list their first cousins. Okay. Oh god. First cousins. For grandparent in grandparents. So for each grandparent, probably got to be a set, yeah. Because we for uncle, let's say uncle, aunt, doesn't matter what the gender is, in family, grandparents, child IDs. If uncle, aunt in now. It can't be equal to these two, otherwise it's actually just our mother or father. No. No, we already know the mother and fathers. It's mother or father, so it's not allowed to be those. Skip mother or father. So we've now got an uncle or aunt who's clearly an uncle or aunt. And any one of their children. So for cousin in family, uncle, aunt. First cousins dot add cousin. So print first cousins. We should now have a set of first cousins. Okay, all of them have them. Okay. First cousins for the grandson. And it's male. Let's just make sure it's male. If family cousin what is it? Gender. That cuts it down. Fine. Now what? Now we've got a list of their cousins. Now we want to say we want to take this cousin, find their grandparents, and if any one of those grandparents is an only child, or cousin in first cousins. So to get all the grandparents, we have to do this process again, but we know... We have to say... Basically do this. This should be a method, really. Let's just say... Define get grandparents for a given ID num. So let's say person equals family. We could have been done by now if we just guessed each of them. I'm trying to solve it. And that would have been the smart thing to do if you were competing for time. I'm just trying to solve it like properly. Person equals family ID num. Grandparents. So we make a list of grandparents. And we say father equals... That's all correct. And then we return grandparents. So this is actually get grandparents of ID num. Take all this out now. Keep the father, mother, because we'll need those. Okay. For grandparents and grandparents, blah, blah, blah. Let's just say C grandparents equals get grandparents of cousin. Let's do that. Just have a look what this looks like. Lots of them, because, yeah, that makes sense. For G in C grandparents. Right. We want to say that this... We're now at this... Wait. Of... So we're now at this bit here. This grandparent here is the only child of X. So they must have a mother and a father. So copy this code here. Equals family of P, I don't know, P equals family of G. Father equals mother equals that. So we've got the mother and the father. If father is -1 or mother is -1, continue. So we have a father or a mother. It doesn't matter which, let's just stick to father. So the father must have... This assumes people don't remarry. Oh god. We'll assume that doesn't happen. If length of family father child IDs is exactly 1, this might be the solution. Print the original person. P you don't want that. Alright, so there's 3 paths, but it's always Winter Kenley. There we go then. This better be it. Woohoo! Took me 2 hours. Well, we got a penalty for like 1 or 2 wrong answers. That was very good. I give that the only 5 because it was... The logic wasn't ambiguous. The puzzles were good. And the coding was actually pretty tough. And I wanted it to be, so... Median is 3 hours, 9 minutes. I mean, it's with a group of people. How did that compare to the last time I did this one? Last time I did it was 2 hours, 31 minutes. So I did it faster this time. Okay. Yeah, it was good. I have no complaint of any puzzle being ambiguous. Okay, there was a weird thing with the looking back through the eyes puzzle. Like, he did say follow back through the guilty looks. I don't know. He said back. He used the word back, so I thought you go back towards the king. But, I mean, it was one of 2 possibilities, so it's not that big a deal. I do still think that was worded wrong, but it's okay. Well, it said took 2 hours, so we took pretty much exactly 2 hours. I think... So for the family tree, like, we saw there were a bunch of females with parents or whatever, and there was like 7 of them. If I had just guessed them one by one, it would have taken me on average like 3 minutes or something. I faster than writing the family tree code. Man of the match, Hex Tree. Well, that's it then. We've done everything. So, like, this used to be a paid subscription, and if you paid, you unlocked, I guess, these four here, which were not good, in my opinion. And I think these were free because they were the competition. Actually, Sherlock might have been a locked one as well. Steamhouse and that one were free because they were like the competition. So I don't think I would have been happy with that, with paying that, because Sherlock was good, but these four were bad. So basically, I would have got like 1.5 hours worth of decent escape room out of that payment. Okay, well, I'm glad they're free now. Because I actually was a couple of weeks ago when I was gonna come back to this, I was actually gonna pay for this as a subscription. But it's free now. That's great. Alright, well, it's a shame they didn't make more of these. I mean, it's a good concept. Um, yeah, okay. Nothing more to say about that. Let's see if anyone else is streaming CodinGame. No, just me. I guess it's only me that streams CodinGame at this time. I know there are other people who stream it, but they stream it at other times, and they're usually based in Europe because this website is not that well known in the US, surprisingly, given that it's basically the best of its kind. I've yet to find anything that delivers these kinds of puzzles, so no upcoming tournaments. Okay. We're done with Coding Escape. The next coding stuff, I guess, will be Advent of Code, but that's gonna happen December, starting from December the 1st up till December the 25th. One puzzle a day. So I don't want to do any more of that, any more coding puzzles until then, because otherwise I'll be overloaded. So see you in December, I guess. See you next time.